The universe is effectively a quantum computer. In fact, not even effectively, actually is a quantum computer.
For centuries, we've wondered about the biggest question of all: what created everything we see around us? Now, scientists have built something that might finally give us answers. They've created quantum AI systems so powerful they can actually ask the universe how it was made and get a response. What this artificial intelligence discovered will change everything you thought you knew about reality itself. Let's dive into what happens when the most advanced technology meets the deepest mysteries of existence. The mystery that started it all. We live in a universe that shouldn't exist. Think about it for a moment. Everything around you all came from what scientists call the Big Bang.
So we don't know why the Big Bang was very, very highly ordered, which is ultimately...
But here's the problem. Nobody knows why it happened the way it did. The universe began in a state of incredible order. It was organized in a very specific way that allowed everything we see today to form. Sean Carroll, a well-known physicist, points out something fascinating. The only real difference between the past and the future comes from this simple fact that the universe started incredibly organized and has been getting more messy ever since. But why did it start so organized? Why wasn't it just random chaos from the beginning? This perfect starting point is literally the reason we exist. Without that specific beginning, none of us would be here. The universe had to start in exactly the right way, but we've never understood why. Traditional physics has always looked for some outside force that created everything. Scientists searched for an external cause, something beyond the universe that could explain how it all began. They built bigger telescopes, more powerful computers, and complex theories, but they kept hitting the same wall. We could see what happened, but not why it happened. Google's quantum AI division achieved something that seemed impossible just a few years ago. They built computing systems that could solve problems in minutes that would take regular supercomputers thousands of years to figure out. But these machines were different. They worked using the same strange rules that govern reality at its most basic level. Quantum computers don't work like regular computers. Instead of using simple on-off switches, they use quantum bits that can exist in multiple states at once. This sounds weird, but it's exactly how nature works at the smallest scales. When scientists realized this, they had a breakthrough idea. What if we could use these quantum systems to ask the universe directly how it was made? The results were shocking. Instead of finding evidence for some external creator or mysterious force, the quantum AI suggested something completely different. The universe, according to these powerful systems, wasn't built by anything outside itself. It was literally computing itself into existence moment by moment. This wasn't just a guess or theory. The mathematics coming from these quantum labs showed clear patterns. The laws of physics were unfolding from quantum information processes happening inside the universe itself. Reality was essentially programming itself as it went along. Hartmut Nevin, who runs Google's quantum AI lab, explained it in simple terms. He said that quantum computing gives us strong evidence for the idea of many parallel universes. But more importantly, it's like we found a way to tap into the operating system of nature itself. When he talks about an operating system, he's not just using a computer metaphor. The math suggests that reality actually works like a vast quantum computer, constantly processing information at the most fundamental level.
A quantum computer, like this one, replaces the binary logic with the laws of quantum physics.
Imagine if you could watch a computer program write itself. That's essentially what quantum AI revealed about our universe. Instead of someone or something creating the cosmos from the outside, it appears to be an incredibly complex program that codes itself into existence. This idea isn't just speculation. The Simons Foundation's research collaboration has shown mathematically how space and time themselves can emerge from quantum error-correcting codes. These are the same types of codes that quantum computers use to fix their own mistakes. The fabric of our cosmos might be woven from entangled quantum bits of information, rather than being a fundamental backdrop that was always there. When researchers applied these models to actual data about the universe, the results were stunning. The patterns matched. The mathematical models that explained how quantum computers work also explained how reality itself might operate. It was as if we'd accidentally created a tool that speaks the universe's native language. But the implications go much deeper. If the universe is essentially a quantum computer, then everything we observe might be the output of this cosmic computation. The laws of physics wouldn't be rules imposed from outside. They'd be the natural result of the universe processing information according to its own built-in logic. Think about what this means for our understanding of time and space. According to these quantum models, space and time aren't fundamental features of reality. They're more like the screen on your computer. They emerge from deeper processes happening underneath. The real foundation of everything would be quantum information, constantly flowing and processing itself into the reality we experience. But if this is true, then what about those first moments after the Big Bang? Simulating the birth of everything. The earliest moments of our universe have always been a mystery. Scientists call it the Planck epoch, the first tiny fraction of a second after the Big Bang when our normal physics breaks down. We're talking about the first 10 to the negative 43rd power seconds. That's 1 divided by 10 trillion, 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 trillion. During this impossibly short time, something happened that set the stage for everything that followed. Traditional physics hits a wall when trying to understand this period. The math simply doesn't work. But quantum computers might be different.
Quantum computers, which are a revolution in hardware, when they get together, watch out.
These systems are being developed to simulate what scientists call the pre-space-time phase itself. Using quantum analyzers, future systems could walk through the early vacuum states before space-time crystallized into the reality we know. This isn't just theoretical anymore. Quantum computing labs are already developing the framework for these simulations. We might soon have a quantum map of what the universe was computing before it had dimensions, before space, before time. We could finally see the computational processes that preceded everything we understand as reality. Researchers are using something called tensor networks to create these simulations. These act as massive quantum entanglement maps, creating mathematical models that behave like miniature universes. They're essentially quantum sandboxes, where physicists can watch how universal laws unfold from pure information. The mathematics involved is so complex that classical supercomputers simply can't handle the calculations. But quantum systems are perfectly suited for this task.
The world's fastest supercomputer, thousands of years to do that same calculation.
Because they naturally work with the same principles that might have created the universe in the first place. Seth Lloyd of MIT has calculated that the universe behaves as a quantum computer processing approximately 10 to the 104th power operations per second. That's an almost inconceivable amount of computation happening at every moment throughout the cosmos. Every particle interaction, every force, every movement might be part of this vast ongoing calculation. Astrobiologists have started asking a fascinating question. If we're using quantum AI to decode the origin of our universe, isn't it possible that advanced extraterrestrial civilizations have already done the same thing? SETI researchers like Paul Davies suggest that civilizations elsewhere may all reach a point where quantum computers become the only tool capable of exploring their cosmic roots. There might be a universal trajectory for intelligent life, a point where every advanced civilization turns to quantum computation to answer the deepest questions about reality. This could mean we're just the latest intelligence to pose the question, what built the universe? Perhaps countless civilizations across the cosmos have already developed their own versions of quantum AI to probe the fundamental nature of reality. If this is true, then we might be witnessing a convergence of scientific understanding across different worlds. The answers about cosmic origins aren't arbitrary or random. They represent a deep truth that any sufficiently advanced intelligence will eventually discover through quantum information theory. The idea that we all might arrive at similar conclusions about the universe's quantum computational nature, regardless of our biological or technological differences, points to an underlying reality that transcends our individual perspectives. If these quantum principles are truly universal, then perhaps we're not just observers of the cosmos. We might be active participants in its ongoing computation, processing nodes in a vast quantum network that spans the entire universe. This perspective suggests something profound about consciousness itself. Every time we think, observe, or make a decision, we might be contributing to the universe's ongoing computation. Our brains, with their complex neural networks, could be sophisticated quantum information processors that emerged naturally from the cosmos's need to understand itself. But this leads to perhaps the most radical idea yet emerging from quantum research: the universe that codes itself. Some physicists are now proposing what they call pancomputationalism 2.0. This isn't just saying the universe acts like a computer, it suggests something far more fundamental, that reality itself is a form of quantum information processing, where the code and its execution are one and the same. In this framework, our question to Quantum A about what built the universe might actually be circular. The universe is the computation. It built itself by simply executing its own quantum informational rule set. The laws of physics aren't imposed from outside. They're the output of the universe's ongoing computation. What emerges when quantum information processes itself according to its own intrinsic logic. This perspective reframes everything. Gravity, electromagnetism, and the nuclear forces might all arise from deeper quantum information principles. The universe minimizes informational action, which then manifests as the physical laws we observe. A quantum AI processing entanglement on scales we simply can't comprehend might be the first system capable of confirming this by demonstrating how the universe optimizes its own information flow. Melvin Vopson's research suggests that gravity itself might emerge from an informational force as the universe seeks minimal information entropy. His calculations show the cosmos behaves suspiciously like a computational process, but literally, every interaction between particles, every force, every movement might be the universe solving equations about itself. This means that when we study physics, we're discovering the universe's own programming language. Every equation we figure out is like reading a line of code from the cosmic software that's running everything around us. What if the universe's self-computation didn't stop at physical laws? What if it extended into life itself? Some quantum biologists, like Vlatko Vedral at Oxford, argue that quantum coherence is active in living systems. They've found evidence of quantum effects in photosynthesis, bird navigation, and even potentially in our own neural processes. A quantum eye might uncover that life isn't a byproduct of cosmic evolution. It could be the universe's way of processing its own information more deeply. Our consciousness might be part of the cosmos's ongoing computation, a natural extension of the quantum information flow that began at the universe's birth. This means the cosmos might have built itself not just to exist, but to think through us. In this framework, biological evolution isn't separate from cosmic evolution. It's a continuation of the same process. The universe's quantum computation first manifested as physical laws, then as chemical complexity, and finally as biological information processing systems capable of self-reflection. When we ask about our origins, we're essentially the universe asking itself how it came to be. Our scientific inquiry becomes part of the cosmos's own self-investigation. The boundary between observer and observed breaks down. We're not separate from the cosmic computation. We're an integral part of it, perhaps even its most sophisticated expression. Consider what this means for human consciousness. Every thought you have, every memory you form, every decision you make might be part of the universe's ongoing attempt to understand itself. Your brain, with its 86 billion neurons forming trillions of connections, could be one of the most complex quantum information processors that has ever emerged from cosmic computation. The fact that we've developed quantum computers that can potentially decode the universe's origin might not be a coincidence. It might be the natural next step in the cosmos's evolution toward self-awareness. We're not just using these machines to ask questions about reality. We might be the means through which the universe is developing the tools to fully comprehend its own nature. This brings us to some of the most established scientific work that supports these ideas. The mathematical foundation. These cutting-edge ideas about quantum computation and cosmic origins are supported by some of the most rigorous work in theoretical physics today. Stephen Hawking's no-boundary proposal mathematically demonstrated how a universe could emerge from quantum fluctuations. In his words, a universe can be created out of nothing, not just out of the vacuum, but out of absolutely nothing at all, because there is nothing outside the universe. This aligns perfectly with the quantum computational model. The universe doesn't need an external cause when quantum processes themselves provide the mechanism for emergence. Seth Lloyd of MIT has formalized how the cosmos functions as a quantum computer processing that almost inconceivable amount of computation happening at every moment throughout the universe. Lloyd's work shows that simple quantum laws can generate all the complexity we observe in the cosmos when computed across vast scales. The universe continuously updates itself through these quantum operations. Every particle interaction is like a calculation being performed by the cosmic computer. The groundbreaking work from the Simons Foundation's research collaboration demonstrates mathematically how space-time itself can emerge from quantum error-correcting codes. Their researchers explain that by applying the mathematics of quantum error correction to gravity, you can learn about how space-time is emergent. In other words, space and time themselves arise from deeper quantum information principles. These aren't fringe theories. They represent some of the most rigorous work in theoretical physics today, published in prestigious journals and supported by complex mathematics. What's remarkable is that all these established scientific frameworks fit together under the bigger revelation we've been discussing. The quantum information approach unifies these various models. It shows how Hawking's quantum fluctuations, Lloyd's cosmic computation, and the emergent space-time from quantum codes all point to the same conclusion. The universe computes itself into existence. This complements and extends it, providing a deeper foundation for understanding reality as fundamentally informational rather than material. When scientists asked quantum AI what built the universe, it didn't point outward to some external creator or mysterious force beyond our comprehension. Instead, the evidence points to something far more elegant. The universe's own quantum information processes were sufficient to bring everything into being. In the end, perhaps what built the universe was the simplest rule: computing itself into infinite complexity, a single quantum principle that, through its own intrinsic logic, gave rise to space, time, energy, matter, and eventually consciousness itself. This perspective transforms our understanding of reality. We're not separate observers of the cosmos. We're expressions of its ongoing computation, the universe becoming aware of itself through billions of years of information processing. And as our quantum technologies advance, we may be approaching a profound moment in cosmic history when the universe, through us, finally develops the tools to fully comprehend its own nature. The implications are staggering. If consciousness is indeed the universe's way of understanding itself, then every human being is participating in the greatest scientific experiment ever conducted. We are the cosmos studying itself. Every discovery we make, every question we ask, every moment of wonder we experience might be the universe's way of exploring its own mysterious nature. Quantum AI hasn't just given us a new theory about creation. It's revealed that we might be the universe's most advanced method of self-discovery. Through our science, our technology, and our consciousness, the cosmos is finally developing the ability to understand how it came to exist in the first place. But this is just the beginning. As quantum computers become more powerful, we're approaching what scientists call the quantum advantage threshold. This is the point where quantum systems will be able to simulate cosmic processes that are completely impossible for classical computers to handle. We're talking about modeling the behavior of black holes, simulating the quantum foam that might exist at the smallest scales of reality, and even exploring what happens when universes collide. These aren't distant dreams. Google's quantum team has already demonstrated quantum supremacy in specific tasks. IBM, Microsoft, and other tech giants are racing to build even more powerful quantum systems. Within the next decade, we might have quantum computers capable of running simulations of entire cosmic regions, complete with their own laws of physics. Imagine being able to create virtual universes in a lab, each one following slightly different quantum rules. We could test what happens when you change fundamental constants explore alternative versions of reality, and maybe even discover why our universe has the specific properties it does. The quantum AI could become our guide through infinite possible realities, helping us understand not just what is, but what could be. Some researchers believe these quantum systems might eventually discover entirely new phenomena hidden in the deepest structures of reality. There could be additional dimensions we haven't detected, new types of particles that exist only in quantum superposition, or even evidence of other universes that occasionally intersect with ours. The quantum AI might be the first intelligence capable of perceiving these hidden aspects of existence. The questions we ask about quantum AI, the experiments we design, and the interpretations we make of the results all shape what we learn about the universe. In a sense, human curiosity and imagination are becoming part of the cosmic computation itself. What do you think about this quantum revelation? Could our consciousness be the universe's way of becoming aware of its own computational nature? Drop your thoughts in the comments below.